Welcome to our channel Circuits Analytica. In this video, we will discuss RC high-pass filter. This is the circuit diagram of a RC high-pass filter. A simple RC high-pass filter consists of resistor R and capacitor C. Output voltage is taken across the resistor R. Capacitive reactance Xc. For a capacitor, capacitive reactance Xc is given as Xc is equal to 1 by 2 pi Fc. When F is equal to 0, Xc is equal to infinity. When F is very low, Xc is very high. When F is very high, Xc is very low. Here F is the frequency of the input signal. Working of RC high-pass filter when frequency F is equal to 0 or when input signal is DC. When input signal is DC, capacitive reactance Xc is equal to infinity. Current flow through the circuit is given as I is equal to V in divided by R minus jXc. As capacitive reactance Xc is equal to infinity, current I is equal to 0. As current I is equal to 0, current flow through resistance R is equal to 0 or voltage drop across resistance R is equal to 0. So output voltage V0 is equal to 0 when input is DC. Now let us discuss the working of RC high-pass filter when frequency F is very low. When frequency of the input signal is very small, capacitive reactance Xc is very high. As Xc is equal to 1 divided by 2 pi Fc. When F is very small, denominator is a value which is very close to 0. That means current I is very small. As reactance Xc is very large. As I is negligible, voltage drop across resistance R is a very small value which is very close to 0. So output voltage V0 is approximately equal to 0 when frequency of the input signal is very low. Now let us discuss the operation of RC high-pass filter when frequency F is in the mid-range, when frequency F is medium. When frequency of the input signal is medium, capacitive reactance Xc is moderate, not so high and not so low. So current starts to flow through the circuit as frequency increases. As frequency increases, capacitive reactance starts to drop, and when capacitive reactance falls, current flow through the circuit starts to increase. When current flow through the circuit starts to increase, output voltage V0 also increases as V0 is equal to I into R. Now let us discuss the operation of the circuit when frequency F is very high. When frequency of the input signal is very high, capacitive reactance Xc is approximately equal to 0. So, current flow through the circuit becomes I is equal to V in divided by R. As I starts to increase, output voltage rises gradually and at very high frequencies, as capacitive reactance is very small, output voltage V0 is equal to I into R, that is V0 is equal to V in divided by R into R, or we can write output voltage V0 is equal to V in. As capacitive reactance is very small, capacitor Xc acts as a short circuit, so output voltage is equal to V in, as the input voltage V in appears across the load resistance R. Output voltage V0 is equal to V in. Now let us discuss the frequency response of a high-pass filter. So this is the frequency response of a high-pass filter. As we can see, at very low frequencies, gain is very small. When frequency of the input signal is less than the cutoff frequency FL, gain of the RC high-pass filter is less than 70.7% of the maximum voltage gain. And as frequency of the input signal becomes greater than cutoff frequency FL, gain of the RC high-pass filter becomes greater than the 70% of maximum voltage gain, or that becomes greater than AVM by root 2. And at high frequencies, as output voltage is almost equal to input voltage, gain reaches its maximum value. Gain is equal to 1. Thanks for watching Circuits Analytica. Enjoy learning.